So in this case, we are going to quickly consider our typical exam revision on our transformers as we managed to work with the introductions and some of the questions similar to this one, actually, as you are going to see. So guys, we're not going to waste much time. We talked about a lot of things about our transformers. So from N5, make sure that you go through your N5 transformers. Yeah, more about it is there. Number 3.1, name two types of variable losses. Variable losses in a transformer. As we have our variable losses, which ones do we have? So the types, guys, for the variable losses, remember we've got the copper losses. So we've got the copper losses, the ones that do happen in the winding. Remember your copper losses, guys, are E squared R. So that is the part that you're going to have. And also we have the stray losses. So this one is just your theory, guys. 2 marks. 3.2, the following test results were obtained from 15 kVA, this and that single phase transformer during testing. And this information, use the table above to calculate the following, this and that, guys. All right, let's figure out for this. I'm just going to take my information separately. Here, I'm just going to take my information, guys. Just forgive me. That's my data here. 15 kVA, we are given our S 15 kVA, 3000 over 500, that is V1 over V2 there. So we've got V1 3000, then V2 500, V1 over V2. All right, so it's V1 over V2. All right, then the frequency, this and that. All right, just know it's a frequency because you're dealing with what? With a single phase. All right, so this is it. So these are the tests like it is operating, and this is what we have. Open circuit test. Let us just talk about open circuit test. So for the open circuit test, they said 500 volts applied to the 500 volt winding. 500 volts applied to the 500 volt. The 500 volt winding is which one? The 500 volt winding is this one, which is the V2. So they are giving us to the secondary side this time. They are giving us to the secondary side. Remember, there are questions where lastly we had where we are given the primary side. This time they're giving us the secondary. So we're going to work with what? Secondary side. The input power, remember, as long we are working with open circuit, guys, it is the input power because open circuit output power is what? It's 0. So the open circuit will be input 140 watts, which you can also write as a in kilowatts. You can divide by 1000, 0.14 kilowatts if you want. You can just work with the watts as they are. All right. Then we move on to the short circuit test. What is it that you are given on the short circuit? 35 volts at nominal frequency being applied to the 500 volts winding. 35 volt at nominal frequency being applied. Guys, which one is the 500? The 500 is what? The secondary. So it is being applied to the secondary, meaning say they're talking about the short circuit of the secondary side. V short circuit 2 is the one that you're given there, 35 volts. So guys, and full load circulating in the 3000 volt winding, that is in terms of this part, remember, in terms of the like the input that you're going to have, and the input power, that is for the short circuit. Again, you'll be using that as your input power. It's for the short circuit. So this is our short circuit, 150 watts, which is 0.15 kilowatts. Simply divide by 1000. You can also have it like that. So that is the conditions, guys. 35 volts at nominal frequency being applied to the what? 500 volt winding. All right. So that is the most important part. We are working with the secondary side. So meaning this time we are actually on the secondary side. The previous case that we had, we worked with the primary side. and the secondary, both we on our example. So it's easier, guys. Remember when I was talking about the short circuit test, we worked with both primary and we also worked with that secondary. So we are going to be working on the secondary side. That is the condition of our question. So the question was, in this case, use that information in that table to find what? To calculate this resistance, reactance, and impedance referred to the what? To the secondary side. Like I was saying, you are working with the secondary side. So these values that they're asking you, they are equivalent values, guys. They are actually supposed to say equivalent. The equivalent what? Resistance, reactance, and so on. So those are the ones that we need. Referred to that secondary. So we need equivalent resistance. You refer to the secondary. The reactance also referred to the secondary. The impedance referred to the secondary. These are the ones that we need. So what can we use, guys, according to the information that we have? We have the information about the open circuit test, about the short circuit test. Sorry, this one. We have the information fully given. With that information, let's use it to find whatever that we can, because we've got this short circuit power and also the voltage short circuit for the secondary. And also our apparent power. Remember, that one is used for the calculation of current. It is used for both the primary and the secondary. I said it. So we can calculate I2 first, because we do not have I2. So let's calculate I2 first. All right. Calculate I2 from what? From S. All right. Remember that S is equal to V1 I1, also V2 I2. If it was V1 I1, it can also be what? V2 I2. As we need this I2, so simply divide by what? By V2 both sides. So that is the case. So it's going to be S over V2. We have this S, 15 kilovolts amperes. That's to the exponent of 3 over V2, which is 500. So dividing this, guys, was going to give us I2, which is 30 amps. So with this I2, working with the short circuit power, working with this short circuit, we can find any one of these, then find what is missing from there. Like we can see, guys, from the short circuit power, working with the secondary side. Remember, we're on the secondary side. So it's I squared 2 RE2. So this is the formula that we're going to use this time. All right. So guys, yeah, there's nothing new here. So that is it, guys, from P short circuit, I2 squared RE2. So we need this, gonna simply divide by what? I2 squared, both sides. So it means our equivalent resistance referred to the secondary side was gonna be calculated, that's from the short circuit over I2 squared. So we have, guys, our short circuit power, 150 over what? I2. We calculated I2, and that was 30. So that's 30 squared. So that was going to give us R2 of 0.167 ohms, just like that. All right. So we move on to the short circuit of the secondary. From the short circuit there, we're going to calculate what? The impedance, the equivalent impedance can be determined. All right. So the equivalent impedance can be determined from there. All right. So let's calculate the equivalent impedance. All right. So this was from the short circuit power. Then from the short circuit voltage as of the secondary side, we saw that it's going to be I2 ZE2, and this is what we need. So we're simply going to divide by what? By I2 both sides. That's it. So guys, it's a matter of formulas. Play around with your formulas, guys. Play around with these formulas. So that's it. We have for the secondary side, the short circuit, this one. That's why we're using the secondary side, because we have that of what? The secondary. If we were to work with the primer, then we have to work with that primer. So that was 35 volts there. That's 35 over I2, which we calculated 30. So that was going to give us 1,167 ohms. Okay. Then from there, we can calculate this, which is our X. We can calculate X, which is our equivalent reactance. Remember, if you have got Z and you have got resistance, X can be calculated. We managed to manipulate, guys, this one and have it as our formula, if you still remember. So that is what we are going to use to calculate X. So therefore there, our X1 was going to be the square root of ZE1 squared minus R. Oh, guys, we are dealing with the secondary side, remember. Now I'm taking the primary. This is secondary side. We are dealing with the secondary side. So that's it. Let's calculate our equivalent reactance. So that's the square root of Z 1,167 squared minus our RE there 0,167 squared. So that was gonna give us the equivalent reactance of 1,155 ohms, just like that. So this is the equivalent reactance referred to the what? The secondary side, as we are referring to the secondary side. So these are the ones that we calculated, guys, and I'm just gonna take these values. Like I said, guys, please just forgive me, guys. This thing, guys, is simply needs us to understand each other. You understand me, I understand you guys, just like that. But remember, calculated I2. That was 30 amps. We calculated this one, 0,167. Especially these ones, we might need them, guys. All right. The Z also and the XE. All right, no problem. Let us continue. Let us continue, guys. 1,167 and XE, we calculated it was 1,155 ohms. I'm just gonna write these values, guys, in case we need any part there. We will simply have to substitute the information that we calculated. All right, let's move on to, so it was 8 marks, guys, just like that, 8 marks. We have 8 marks. As you see, exam is easy, guys, to totalize. All right, 3.22, the percentage regulation at full load and 0,85 power factor lagging percentage regulation. This one is straight your N5. Straight your N5 calculating of the percentage regulation. Remember, these ones can be used, referred to the primary, referred to the secondary. This is the one that you're going to work. As we can see, guys, according to the values that we are given, this is the best formula because we have values that were referred to the what? To the secondary from the I2, this, everything there is referred to what? To the secondary. And it's a power factor of what? Lagging. A lagging power factor must add. So we are going to take the one with what? A positive. Lagging. We add. So this is the one. This one is limited this time because we do not have information for the primary side. We have to calculate these guys. We do not have that. So look, guys, 2 marks. For those 2 marks, we now start to calculate. Oh, it's exam. You do not have all that time. So that is it, guys. As we can see, according to our information, this is what we have, and I'm gonna use that one. So let's calculate our percentage what? Regulation 3.22. All right, so that's our, actually there they say the percentage. All right, so it's percentage that they want. So percentage, you multiply by 100%, whatever formula that you're gonna have, you're gonna multiply by 100%. If it is per unit, do not multiply by 100%. So like I said, we are going to use the secondary side as referred to the what? As referred to the secondary side. This is the information that we have. So that's going to be cos phi. So this one is just cos phi. Do not mind. The 2, we are just using it as a symbolism of saying we are using what? The secondary side. But it's the same cos phi that we are using there. All right. Then we're going to add, since it's a lagging power factor. All right. Then according to our formula, guys, this is just your formula. Know your formulas. Know your formulas, guys, over what? Over V2. And this is the original V2 that we had originally given here. The one that we had originally given here, guys. Here, originally given our V2. So that is it. According to our information, remember they said it's power factor at what? 0.85 power factor lagging. I mean, power factor of 0.85. So we're going to need the angle that we'll use to find the sign there because we do not have that sign. We have the cos. Power factor, it's cos. So meaning to say from our power factor, meaning to say we've got cos phi 2. All right, which is from that cos 0.85. So you're going to find our angle. Remember, that's arc cos. So it's arc cos of the decimal that you're given here from your calculator. That was going to give us 31.788 degrees. We have cos phi and this or phi. Use now to find what sine. So the sine of phi is going to be what? Sine of this. So it is simply sine of this angle that we see. So it was going to be 0.527, something like that. 0.527. So this is what we need on our formula. This is also what we need on our formula with all the other values that we calculated before. This I2, this and that. Like I said, working with the secondary side will be easy because information is already readily available. It is just a matter of substituting. The only part that we needed was this. Okay, so if you know your formulas, guys, it will be easy. So percentage regulation, let's calculate this one. I2, that is 30. So that's 30 into what? The equivalent resistance there, it was 0.167 times the power factor cos phi, there's 0.85. Okay, then we're going to add since it was a lagging. All right, then equivalent reactance, we calculated this, it was 1.155 times the sine of phi, which we calculated 0.527. All right, so like this, everything over what? V2, the original voltage that you're given, which is our V2 there, which is 500. That was 500. All right, so this is it. With this whole information, since we need a percentage regulation, we're going to multiply by 100%. So that was going to give us the percentage regulation, guys. Make sure you use your calculator properly. And this was going to be very small, 4.5. It was going to be 4.504, 3 decimal places. So this is what you were going to simply obtain, just like that. Just like that. All right. So this is it, guys. Just a matter of substituting. Take note the information. How are you given the information? For which conditions are you calculating that percentage regulation? For which conditions? All right. So that one was your N5. Like I said before, please do revise your N5 in as much as you can. Then the other part was to calculate the efficiency. All right. So for efficiency, we do not need this, guys. Let me just erase this. So they want us to determine the efficiency at full load. So this one, guys, is at full load. Remember, at full load, K is equal to 1. The conditions for efficiency at full load, the factor of full load. At full load, K is what? K is 1 at full load. So we must know our conditions, guys. So we know that for our efficiency at full load, as we are given at full load, K is equal to 1. Then they said, and 0.85 power factor lagging. So we also have cos phi in that case, which is what? 0.85. This is the only part that we need, guys. It's not something that is extra, guys, where we are calculating the efficiency at maximum efficiency. What? This is just a normal efficiency. At full load, you just know your case one, then you substitute everything into the formula, the original formula, this one, for your efficiency at any load. So that was the case, guys. Just simple like that. Just gonna substitute our values here. So we saw that our efficiency can be calculated from Ks, that's cos phi over Ks cos phi like this, plus P open circuit plus K squared P short circuit times what? 100%. So substituting these into our formula was going to give us our efficiency, our K, remember at full load, that's 1. So that's 1 times. So guys, I explained this. I'm going to explain it again, that if you are given the kilovolt amperes, it's up to you. You can change it to the volt amperes multiplied by 1000. When you do so, make sure that the open circuit and the short circuit, these ones are in what? In watts, as they are, in watts. But if you use the kilovolt amperes, this one, at the moment you just use the kilovolt amperes, here, if this is kilovolt amperes, make sure that your open circuit is in kilowatts. Same with this one for the short circuit, kilowatts again, kilo, this part. So it is up to you. You can change this one, guys, 15,000. The moment you write this one as 15,000, right? The moment you write is 15,000. Make sure that on the open circuit, you are going to write what? 1/4. Make sure that this one is going to be 150. It's up to you. Or you can maintain the 150 as it was. I mean, this 15 kilovolt amperes. Kilo. You maintain the kilo on the other ones. All right. So as for me, guys, I'm just going to use the kilo the way that it is. No problem. As for you guys, use the way that you understand, guys. It is in your hands. This part, guys, it is in your hands. If you want to use that, you can use that. If you want to use the kilo, use the kilo. It is in your hands. So that was 15 kilovolt amperes times cos phi, which is our power factor. 0.85 everything over what? 1 times 15 times 0.85 like this, plus our open circuit. Since we used the kilovolt amperes, we're going to use the kilo values. Our values will be kilo. So open circuit 0.14. That's 0.14 in kilowatts. All right. So this is in what? Kilowatts, like this, plus that is K squared. K is 1, guys, does not even affect 1 squared, is just 1. All right. Our short circuit, remember, we have that one as 15 watts. It was 150 watts as a decimal, I mean, as in kilowatts, 0.15. So that is it, 0.15. You can choose, guys, to maintain them as they were. It is also in your hands. So that was going to give us our efficiency of 97.776% at full load. This is at what? At full load. So the type there, the K, this part of K, was going to change if they mentioned anything about this load. If they just say it is 3/4 or what, it changes. The decimal part, is it half load? Is it 75? Is it 1/2, 3/4, whatever that you're given? Is it at maximum efficiency? The K has to change. You must calculate the new K. So revise, guys, your basics. This is how these questions might be given as. So as we can see, guys, we still need our N5 information and N6, because if you check the most part, especially this part here, the 10 marks here was actually N5. N6 is just 2 marks. So you see, N5 is still very, very important. So let's do revise as much as we can till we meet again.